Our last section, our last chapter, here we go. It's on surface area and volume, which kind of goes hand in hand with our last lesson or last chapter. So last chapter is all about finding the area of like just plain figures, a triangle, a hexagon, a rectangle, whatever. And now we're putting them together to make a solid. So it's three-dimensional. So that's what's different, okay? So let's talk about these solids and give some new vocabulary into our warehouse here. So a prism is just a solid figure made up of bases and lateral faces. The bases of your shape, your solid, are the two congruent sides that are parallel, meaning they would never touch. So like on this guy, they'd be the hexagons. So you guys see how they're the exact same shape, but they'll never touch because it's kind of like the top and bottom. That's how you name it, the base shape, okay? Whereas the lateral faces, like the lateral pass in football is like the sides, right? So like your lateral faces are typically all these rectangles that build up your prism. The altitude or height is the perpendicular segment between the bases, so the height of how your prism, how tall it is. And kind of like I just said, you name a solid by its base shape. So like this would be a triangular prism, hexagonal prism, square, pyramid. You name it by the bottom, its base shape, okay? So on this example up here, what do we have pictured? Yeah, that's a hexagon, right? So hexagonal prism. That's what we would call it. All right? So when we find the surface area, you can think of it in two different things. The lateral area, that's the sum of all the sides, right? The non-bases. The wraparound area is another way to think of it. And the base area would be like your top and bottom. And then to find the total surface area, we add both of those up. So if you were like wrapping something for Christmas, how much wrapping paper would you need? That's its surface area. If you were to send something in the mail and you had to wrap it, how much wrapping would you need? That's surface area. Okay, we're just gonna get rocking right away. Find the surface area of this prism, round to the nearest tenth if necessary. What would you guys call this? Rectangular prism, right? Now the problem with a rectangular prism, any two pairs of sides could really be the base, right? Because are these two sides the same and never gonna touch? What about these two? And these ones? So it's a little different compared to like a hexagonal prism, right? Where I know my bases are just the hexagons. So when we find the surface area of this one, I kind of like to label it a little differently. I do like bottom and top. And I'm going to be a little bit more detailed with your notes just so you can kind of see where we're getting these numbers from. So if I trace out that bottom rectangle, what are the dimensions of that rectangle? Yeah, 4 and 12. So 4 times 12. And can you guys agree that the bottom and top of this rectangular prism are the same? So I'm going to multiply it by 2 to save ourselves some space. Or time, not space, time. So what is that? 4 times 12 times 2.
88.
So close.
No, 96.
There you guys, if you're real close, 96. All right. What if we did the left and right walls? Left slash right.
4 times 12.
It is 4 times 12. And does it make sense that we're multiplying by 2 since these two are the exact same on the box? And we already know that's 96. Now we just have that front and back wall, that little guy. Front, back. What are the dimensions of that?
4 times 4.
4 times 4. Is it okay if we multiply by 2 since it's a front and back that are the same?
Yeah.
Okay, what does that give us?
32.
32. So now our total surface area, we just add those 3 numbers up. You guys just let me know what you get. I could do it too, I suppose. What do you get, Taylor? 224. Are you guys all right with that?
Yes.
Inches squared because it's area. All right, the next one, they don't give you a picture, so it's kind of hard to think 3-dimensionally when it's not shown to you. But I have a visual right here, which is nice. We have a regular hexagonal prism with a side length of 5 and a height of 12. So when you're not given a picture, I think the best thing to do is to draw your base shape. What's our base shape on this guy? Yeah, draw yourself a hexagon. To your best of your ability, I can't draw to save my life. It's not regular looking, but this is what I can show you. That's pretty ugly. Sorry, guys. On our turn. She got a little weird over here. Try to fix that quick. Okay, so you have your base shape, right? And we know that it has an edge length or a side length of 5. So I know this is 5. So now you're relying on that information from last chapter. Do you guys remember how to find the area of this guy? Yep. So we need our apothem and our perimeter. Perimeter's pretty easy on this one, right? Yep, 5 times 6 is 30. We gotta draw on our triangle. I'm gonna make it big right here. What do we need to find in that triangle? The long side, yep. Do we know what this angle would be? 30?
Yeah.
Okay. Do we know this bottom one? So close.
2.5.
Yep, 2.5. So if we have our short side, we get our long side by multiplying by. Yep. I think it's 4.3. Someone should check my memory though. Okay. There we go. That's our A. So now our base area, half our apothem times our perimeter. How many bases do we have though? So we're going to multiply it by 2. You guys let me know what we get for that.
128. 129. Right?
Is that okay? I don't know. Should I type it out? Do we trust Julia?
Yeah, it's 129.
129? Okay. So as of right now, we've just gotten these guys. Our hexagons. Now what makes up the lateral walls? Rectangles. Okay? So close. We know our base length is 5, but how far back do they extend?
12.
12. So 5 by 12 times how many?
6.
Do it. Lateral area. 5 times 12.
360.
Yep, it is 360.
Yeah, I don't know.
Now we add them together for our total surface area. Okay. 489 centimeters squared. It's a lot. I know that it's a lot to keep track of. It's hard to think 3-dimensionally and it's super humid in here and it feels gross. That's what I think. Like I'm like, ugh, gross. Okay, when you're ready, flip the page. We're gonna skip this one. This is just another rectangular prism. I don't think we need to do another one. If you want to do with me later, I'll sit with you. But we have folks leaving for sports, so I just kind of want to get through everything else. But let's do this cheese one. Cheese. Okay. It says a piece of cheese is in the shape of a triangular prism, a shrink wrap for sale. The base is a right triangle with legs 3 centimeters and 4 centimeters. The height of the piece is 4 centimeters. What's the surface area of the shrink wrap? What's our base shape? What's our base shape? Triangle. Does it say specifically what kind?
Right triangle.
Right. So draw that. Draw a right triangle. And it says we have legs that are 3 and 4.
3 times 4 divided by 4. No. So it's 6.
So if we start with our base area, that's triangles, right? So base area. How do you find the area of a triangle?
Base times side divided by
Yep, and Julia's saying 4 times 3 divided by 2.
6.
I forgot. I'm sorry, Lataeus. I'll remember next week. I know. I suck. Like, we all know this. I suck. I'm sorry. How many bases do we have? 2. So we got to multiply this by 2.
Wait, what did you forget?
I don't know. I forgot to put the box, so
Let's say it's not happening.
yeah, he's I know, but he asked me to do it, and I just, Okay, what did we get for our total base area?
You literally 3 times 4.
And you could, but the thing is, once we get through all of our solids, you're going to forget about that half, and you're going to be multiplying by 2 when you don't need to. So that's why I still write it out like this. So we should just be getting 12. Okay. Now if we look here, what shape is our lateral area? Squares, rectangles, right? Who's to say? They would be rectangles here though. So lateral area. I'm gonna try to draw it. It's gonna go back like this. Does that kind of work? Can you kind of see it?
Yeah.
Okay.
What?
I'm drawing a 3-dimension. I know it's tough. This is 4. So this bottom rectangle, what are the dimensions of it? 4 times 4. Now for a triangular prism, you don't multiply by 2 because it's not a box, right? There's only one side that matches it. So 4 times 4 is 16. If we do this side over here, what are the dimensions of it?
16.
3 and 4, right?
12.
3 by 4, which is 12. Now the problem is, do we know what this length is?
No.
Can we find it?
Yeah.
Yep, you gotta do it. Your favorite guy, Pythagorean, pulling through it once
Is
again.
it like 5? Is it like 5?
But you guys, be smart. Just type this in your calculator just like this. Don't do every step. Use your calculator. 3 squared plus 4 squared is
25.
Square root of 25
5.
is 5.
So.
So what's the dimensions of this slanted rectangle?
5.
5 times 4, which is 20. So I gotta add all 4 of those up. I know. I don't remember.
You got 16.
I got 60. Unless I did it wrong 3 times today, which I could have.
It's the 4 numbers.
Oh, it's
Right,
4 of them.
this
I was
guy,
ten.
this guy, this guy,
Oh,
and
it's
this guy.
6, not 12.
60 centimeters.
I guess I wrote 6.
Do the square ones.
Yeah, but you guys will like cylinders because you know why? They're all the same, so you get a formula. Woo! Okay, we did the hard stuff first. Are you ready to coast?
Yeah.
Okay, because it's tough in May. We got 14 days.
Wait, was it? That's it?
Wait. Okay, what are your base shapes on a cylinder? Circles. How do you find the area of a circle?
The thing
Pi r squared.
Pi r squared. And we have 2 of them. So 2 pi r squared. That's your base area. And then your lateral area, 2 pi r h. And just make sure you copy that down correctly because then all these cylinder problems become much easier as long as you have the correct formula. And now it becomes calculator work. But on your homework, I want to see what you typed into your calculator, so like one step, okay? So this first one, what is our radius of our cylinder?
15.
Well, I don't know if it's,
7.5.
oh, then it's.
Half of this, right?
Oh, that makes it look like
7.5.
Why they put it on one side?
yeah, that makes it look like it's 15.
If the whole line's drawn, it's the diameter. If the red line would have stopped here, it's just talking about the radius. 2, 7.5. How tall is our cylinder?
15.
18. It's laying on its side. Type this in one step. See if you get the same thing. Type it in. Be efficient, mathematicians. Use your tools correctly. Make your life easier. If you're not getting approximately 1,201.7, will you wave me over? That just means you might have hit the wrong button.
No.
He was looking at me.
If you got that, will you try the next one and I'll catch up to you? Try the next one and I'll catch up to you.
This is after
Light.
Oh, good. Good. I don't like wearing ever. But I have to sometimes.
Just put a parenthesis here. I'm gonna delete.
Are we close?
The more you know.
Did we get it? Well, you guys do this. We have one more to do.
Okay.
And then we'll let this go. You're okay. Just making sure we're all right for the last one. Okay, last one here. Cherie, use the rectangular piece of felt shown at the left, not right, to cover the curved surface for her cylindrical pencil holder. The circumference corresponds to the side measuring 12.6 inches. What is the surface area of the entire pencil holder to the nearest tenth? So our goal is to find the surface area of a cylinder. But before we can do that, what do we need to figure out? The radius. And the key thing there is we know the circumference of our circle is 12.6. Not quite. Circumference is 2 pi r. Twinkle, twinkle, little star. Circumference is 2 pi r. No? Okay. We know that is 12.6. We gotta get our radius to plug into our other formula. How do we get r alone? Divide by 2 pi. Here's the deal though, your calculator is really not that smart. You gotta divide with this in parentheses. 12.6 divided by 2 pi in parentheses.
So 12.6 divided by 2 parentheses.
Put 2 pi in parentheses if you get it wrong.
And we use the equation.
So now that we know our radius, we can plug in. Do we know our height?
Is that 5?
It is 5.
87, no, 88.
88 inches. Okay.